Hello there, and welcome to Earth's History, where we venture beyond our world, where we explore possibilities written in the geology of our sister planet, where we ask whether humanity might not be the first civilization in our solar system, but merely the inheritors of a story that began on another world entirely. Tonight, we're embarking on one of the most extraordinary journeys in speculative science and planetary archaeology. What if Venus, that hellish cloud-shrouded inferno, now with surface temperatures hot enough to melt lead and atmospheric pressure crushing enough to destroy spacecraft in minutes, was once a paradise? What if billions of years ago, when Earth was still a lifeless rock, Venus harbored oceans, continents, and the first intelligent civilization in our solar system? What if everything we think we know about life's origins, about our place in cosmic history, about the development of intelligence and technology, needs to be rewritten because the first chapter wasn't written on Earth at all, but on the planet that now blazes in our evening sky as the brightest object after the sun and moon? If you've ever looked at Venus in the twilight and felt an inexplicable connection, if you've wondered why our nearest planetary neighbor is so similar to Earth in size and composition, yet so utterly different in conditions, if you've considered that the 4.5 billion year history of our solar system is long enough for entire civilizations to rise, flourish, and vanish before Earth even developed life, if you've contemplated that the ruins of ancient cities might exist not in our own deserts, but on planets we've barely begun to explore, you're touching on a possibility that transforms everything. The Venusian civilization hypothesis isn't just science fiction. It's a framework supported by planetary science, orbital mechanics, climate modeling, and our growing understanding of how planets evolve over geological time. It's a hypothesis that explains mysteries, suggests investigations, and reminds us that in the vastness of cosmic time, we might be newcomers to a solar system that has already seen intelligence bloom and fade. Wherever you are right now, I hope you're comfortable, settled, ready to journey across space and time to a world that might have been the cradle of the solar system's first technological species, ready to imagine oceans that once lapped on Venusian shores, cities that once gleamed under a yellow sun seen through breathable atmosphere, beings who looked at the night sky and wondered about other worlds just as we do, never imagining that one day their own planet would become uninhabitable, and their story would be forgotten, except as speculation by creatures on a neighboring world who call themselves human. If this exploration into Venus's possible past changes how you think about planetary evolution, if it makes you wonder what evidence of ancient civilizations might still exist in our solar system waiting to be discovered, if it inspires you to look at planetary science with new questions about what we might find, I'd be grateful if you'd like the video, subscribe to the channel, or share it with someone else who understands that the universe's story is far longer and stranger than we typically imagine. So settle in. Let your breathing slow like the patient orbits of planets around our star. Let your mind expand across the inner solar system, across billions of years, across the possibility that intelligence is older than Earth, that civilization predates humanity, that the first beings to ask why and what if might have done so on a world we now consider the solar system's most inhospitable hell. And let's begin our investigation into whether Venus, before it became the inferno we know today, might have been home to the solar system's first civilization, and what that would mean for our understanding of life, intelligence, and our place in cosmic history. Venus Today, Portrait of Hell. Before we can imagine what Venus might have been, we must understand what it is now. A planetary environment so extreme that it seems designed to destroy anything we send there. The numbers. Venus is Earth's near twin in terms of size and composition. It has 95% of Earth's diameter, 82% of Earth's mass, and similar overall density, suggesting a similar internal structure: iron core, rocky mantle, silicate crust. It orbits at 0.72 AU from the Sun. Earth orbits at 1.0 AU, receiving about twice as much solar radiation as Earth. It completes one orbit in 225 Earth days. But the similarities end with size and composition. Venus's environment is catastrophically different. Surface temperature. The average surface temperature on Venus is 462 degrees Celsius, 864 degrees, hot enough to melt lead, zinc, and tin. This is hotter than Mercury's sunlit surface, despite Mercury being much closer to the Sun. The temperature is remarkably uniform across Venus. Dayside, nightside, equator, poles, all within a few degrees of this infernal average. No place on Venus offers relief from the heat. Atmospheric pressure. At Venus's surface, atmospheric pressure is 92 times Earth's sea level pressure, equivalent to being 900 meters underwater in Earth's oceans. This pressure is sufficient to crush most spacecraft and submarines. Standing on Venus's surface, if you could survive the heat, would feel like being at the bottom of an extremely hot ocean made of supercritical CO2. Atmospheric composition. Venus's atmosphere is 96.5% carbon dioxide, 3.5% nitrogen, with trace amounts of sulfur dioxide, water vapor, carbon monoxide, argon, and other gases. The CO2 creates a runaway greenhouse effect, trapping heat and preventing it from radiating back to space, maintaining the extreme surface temperatures. Cloud layers. Venus is perpetually shrouded in thick clouds composed of sulfuric acid droplets, extending from about 50-70 kilometers altitude. These clouds completely obscure the surface from visible light observation from space. No spacecraft has ever photographed Venus's surface from orbit in visible light. The clouds reflect about 75% of incoming sunlight, making Venus the brightest planet in Earth's sky, but ensuring the surface exists in eternal twilight, never seeing direct sunlight. Rotation. Venus has the slowest rotation of any planet. One Venusian day lasts 243 Earth days. Stranger still, Venus rotates retrograde, backward compared to most planets, meaning the sun rises in the west and sets in the east. Why Venus rotates so slowly and backward remains a topic of scientific debate. Possible explanations include a massive ancient impact, tidal effects from atmospheric friction, or resonance with Earth's gravity during close approaches. Lack of magnetic field. Unlike Earth, Venus has no significant magnetic field. Earth's field is generated by the dynamo effect in our liquid iron outer core, but Venus either lacks a liquid core or its rotation is too slow to generate the dynamo effect. Without a magnetic field, Venus's upper atmosphere is exposed directly to the solar wind, which strips away lighter elements over time. Volcanic activity. Venus's surface is geologically young, roughly 300 to 500 million years old based on crater counts, suggesting recent in geological terms, massive resurfacing, probably through volcanic activity. Venus has more volcanoes than any other planet in the solar system, with over 1,600 major volcanic features identified and possibly hundreds of thousands of smaller ones. Some scientists believe Venus might still have active volcanism, though this remains debated. Surface conditions. Soviet Venera landers that reached Venus's surface in the 1970s-80s transmitted data and images for brief periods. The longest surviving, Venera 13, lasted 127 minutes, before succumbing to heat and pressure. Their images show rocky landscapes, flat plains of basaltic rock, and in some images what appear to be sedimentary layers, suggesting possible ancient water activity. The surface is mostly basaltic volcanic plains, 80% of the surface, with two major highland regions, Ishtar Terra, size of Australia, in the northern high latitudes, and Aphrodite Terra, size of Africa, near the equator. Why Venus is hell. The runaway greenhouse effect explains Venus's current state. Carbon dioxide in the atmosphere traps infrared radiation. As temperature increases, any surface water evaporates, adding water vapor, also a greenhouse gas, to the atmosphere, increasing temperature further. Eventually, all water is in the atmosphere, where solar ultraviolet radiation breaks H2O into hydrogen and oxygen. The lightweight hydrogen escapes to space, the oxygen combines with surface rocks, and the water is permanently lost. With no water and no carbon cycle to remove atmospheric CO2, on Earth, CO2 dissolves in oceans and is sequestered in limestone. CO2 accumulates from volcanic outgassing, creating ever-increasing greenhouse heating until equilibrium is reached at the current infernal conditions. This is Venus now, a world seemingly designed to obliterate life. But was Venus always like this? The answer from planetary science is a definitive no. Venus has not always been hell, and in that answer lies the possibility that Venus was once very different indeed. Ancient Venus, paradise, lost. The scientific consensus, based on planetary formation models, isotopic analysis, and climate simulations, is that Venus was likely habitable for much of its early history, potentially for billions of years. Venus formation and early history. Venus and Earth formed at roughly the same time, about 4.5 billion years ago, from the same protoplanetary disk of dust and gas orbiting the young Sun. Early Venus likely had conditions similar to early Earth, a molten surface that gradually cooled and solidified over tens of millions of years, bombardment by asteroids and comets during the late heavy bombardment, approximately 4.1 to 3.8 billion years ago. Delivery of water via comets and water-rich asteroids, volcanic outgassing creating a primordial atmosphere. The faint young sun, paradox. Here's a crucial fact. The sun was about 30% dimmer 4 billion years ago than it is today. It has been gradually brightening throughout its lifetime due to increasing hydrogen fusion in its core. As hydrogen converts to helium, core density increases, fusion rate increases, luminosity increases. This creates the faint young sun paradox. With 30% less solar radiation, early Earth should have been frozen solid, yet we have geological evidence of liquid water as far back as 4.4 billion years ago. The same faint young sun that made Earth's early habitability puzzling made Venus's early habitability almost certain. With the sun providing 30% less radiation, Venus would have received only about 40% more solar energy than Earth rather than double, as it does today. This places early Venus within or near the continuously habitable zone, the orbital range where liquid water can exist long-term. Climate models of early Venus. NASA scientists, Wei et al., 2016, Wei and Del Genio, 2020, created sophisticated 3D climate models simulating ancient Venus with different assumptions about solar luminosity at different periods in the past, atmospheric composition, varying CO2 levels, presence of nitrogen, water vapor, rotation rate, modern slow rate versus hypothetically faster ancient rotation. Topography, using actual Venus topography from radar mapping. Ocean depth, from shallow global oceans to deep oceans covering most of the planet. The results were striking. These models show that Venus could have maintained liquid water oceans and habitable surface temperatures for up to 2 to 3 billion years, from roughly 4.2 billion years ago to perhaps as recently as 700 million years ago under plausible conditions. Key findings. With enough water to form oceans and moderate CO2 levels, ancient Venus could maintain surface temperatures between 20 to 50 degrees C, 68 122 degrees Celsius, warm but habitable. Even with slow rotation, same as today. Atmospheric circulation patterns could have prevented runaway heating cloud coverage over oceans, similar to Earth's tropical cloud systems, would have reflected enough sunlight to counteract Venus's closer proximity to the Sun. The topography of Venus, with its two major continents, Ishtar and Aphrodite Terra, and vast lowland plains, is consistent with a past where the lowlands were ocean basins and the highlands were continents evident in Venus's atmosphere. Though Venus's surface is now bone dry, the atmosphere contains clues about past water. Deuterium, hydrogen ratio. Deuterium, heavy hydrogen, is about 150 times more abundant relative to hydrogen in Venus's atmosphere compared to Earth's. This suggests Venus once had much more water, but it was lost over time. Ultraviolet radiation breaks water, H2O, into hydrogen and oxygen. Lighter hydrogen escapes to space more easily than heavier deuterium, so over billions of years of water loss, the remaining hydrogen in the atmosphere becomes progressively enriched in deuterium. The current ratio suggests Venus once had water equivalent to at least an Earth ocean, possibly much more. Oxygen isotopes. Similar isotopic fractionation is seen in oxygen isotopes, consistent with massive water loss over geological time. Atmospheric escape measurements. The European Space Agency's Venus Express mission, 2006-2014, measured current rates of atmospheric escape and extrapolated backward, confirming that Venus has lost massive amounts of hydrogen, and by implication water, over its history. Surface geology. Venus's surface, mapped by radar from the Magellan mission, 1990-1994, shows features that might indicate past water activity, possible ancient shorelines. Some researchers claim to identify features resembling shorelines or beach terraces at certain elevations in the highlands, suggesting past ocean levels. This is controversial because alternative explanations exist, volcanic or tectonic features, but the possibility remains. Tesserae. These are the oldest terrains on Venus, highly deformed, fractured regions of highland crust. Their formation mechanism is debated, but one hypothesis is that tesserae formed through crustal deformation in the presence of water, similar to Earth's continental crust formation. If true, tesserae would be remnants of ancient continents that existed when Venus had oceans. Low volcanic plains. Covering 80% of Venus, these plains could have been ocean basins that were later filled with lava during the catastrophic resurfacing event 300-700 million years ago. The flatness and basaltic composition are consistent with seafloor basalts on Earth. Possible sedimentary rocks. Some Venera lander images show layered rocks that resemble sedimentary formations. Sedimentary rocks require water-based weathering and deposition, so if these interpretations are correct, they'd be direct evidence of ancient water processes. The habitable window. Synthesizing all evidence, the likely scenario is 4.5-4.2 billion years ago. Venus forms, cools, solidifies, is bombarded by impacts delivering water. Surface is molten or partially molten, not yet habitable. 4.2-2.5 billion years ago. Venus has temperate climate, liquid water oceans, possibly covering 60-80% of surface. Continents, the current highland regions. Stable climate maintained by water cycle and carbon cycle similar to Earth's. Atmospheric pressure, likely several bars, higher than Earth's. Composition primarily N2 and CO2 with significant water vapor. Temperature moderate, 10-40 degrees C range. This is when Venus was most Earth-like and potentially habitable. 2.5-0.7 billion years ago. Gradual transition period as the brightening sun increases solar radiation. Venus begins losing water. Ultraviolet radiation breaks water molecules. Hydrogen escapes. Oceans gradually evaporate. Increasing atmospheric CO2 from volcanism without oceans to sequester it. Climate warming but possibly still habitable in some regions. Polar areas, high elevations, subsurface environments. 700 million years ago. Catastrophic transition to runaway greenhouse. Possible causes. Volcanic mega-eruption event, like Earth's Siberian traps, but planet-wide. Sudden loss of remaining ocean leading to runaway greenhouse feedback, or gradual accumulation of factors reaching critical threshold. Venus's entire surface resurfaces through massive volcanic activity, releasing enormous amounts of CO2. Any remaining water is lost. Venus transforms from habitable world to hellscape in geologically brief period, perhaps 10-100 million years. 700 million years ago to present. Venus as we know it, hot, dry, crushing atmosphere, slow rotation, no magnetic field, volcanic surface. This timeline means Venus was potentially habitable for over 3 billion years, longer than Earth has had complex multicellular life. If life arose on Venus during its habitable period, it had enormous time to evolve, potentially even to intelligence. And if intelligent life did arise, it had one terrifying challenge. What do you do when you realize your world is becoming uninhabitable and you have a neighboring planet, Earth, that might be your only refuge? The Drake equation for Venus. Could life have arisen? The Drake equation, formulated by astronomer Frank Drake in 1961, estimates the number of active, communicative extraterrestrial civilizations in our galaxy. Let's adapt it for Venus to estimate the probability that intelligent life arose there. The standard Drake equation, N, Xia, R, X, FP, X, NE, X, FL, X, FI, X, FC, XL, where N, all were number of civilizations in our galaxy. R, Sha, rate of star formation. FP, Sha, fraction of stars with planets. Ni, Nira, average number of habitable planets per star with planets FL. Yara, fraction of habitable planets where life develops. Phi, fraction of life. Bearing planets where intelligence evolves. FC, fraction of intelligent species that develop detectable technology. L, length of time, civilizations remain detectable. For Venus, we simplify because we're asking about one specific planet. P, Venusian civilization. Now, P, life. X, P, intelligence, life. XP, civilization, intelligence. XP, survival long enough to matter. Let's evaluate each factor. P, life. Did life arise on Venus? This depends on whether Venus's habitable period provided conditions suitable for abiogenesis, life's origin from non-living chemistry. Requirements for life. Liquid water. Venus almost certainly had this for billions of years. Energy sources. Venus had sunlight, photosynthesis pathway, geothermal heat, chemosynthesis pathway, possibly lightning, UV radiation, multiple energy sources, chemical building blocks. Venus's early atmosphere likely contained H2O, CO2, N2, possibly CH4, NH3, all the necessary elements, C, H, N, O, PS, for organic chemistry time. 3+ billion years of habitable conditions, more than enough for abiogenesis trials, protection from radiation. With an atmosphere and possibly magnetic field, if Venus rotated faster in the past, adequate protection. Earth developed life remarkably quickly. Evidence of microbial life exists from 3.8, 4.0 billion years ago, within a few hundred million years of Earth becoming habitable. If abiogenesis is relatively easy, given right conditions and enough time, Venus likely also developed life. Some astrobiologists argue that life might have even arisen on Venus first, being habitable slightly earlier as the faint young sun was less of an issue there, and then transferred to Earth via panspermia, microbes hitching rides on meteorites ejected from Venus by asteroid impacts. Venus is a more efficient source for transferring life to Earth than Mars, despite Mars being more commonly cited, because Venus-Earth transfers require less velocity change and occur more frequently. Estimate: P life, 0.5, 0.9, moderately high to very high probability. P intelligence, life. Did intelligence evolve? On Earth, life arose quickly in first billion years, but intelligence took nearly 4 billion years, most of Earth's history. Multicellular life didn't appear until about 600, 800 million years ago. Animals with complex nervous systems emerged only in the last 500+ million years. Human-level intelligence in just the last few million years. Key questions. Is intelligence an inevitable outcome of evolution, given enough time? Does intelligence provide sufficient survival advantage that it's selected for? Are there specific environmental conditions that promote intelligence evolution? Arguments for intelligence being likely. Convergent evolution. Intelligence, problem-solving ability, learning, tool use, has evolved independently multiple times on Earth. Mammals, birds, cephalopods, even some invertebrates show significant cognitive abilities, suggesting intelligence provides advantages across diverse lineages. Arms races, predator-prey dynamics, social competition, environmental challenges, all create selection pressure for better brains, more sophisticated behavior, strategic thinking. Time. Venus had over 3 billion years. Earth went from single-celled organisms to humans in about the same time span. If Venus had comparable time, intelligence could have emerged. Arguments against contingency. Human intelligence might be a lucky accident, dependent on specific evolutionary sequence that's unlikely to repeat. Diminishing returns. Intelligence is metabolically expensive. Human brains consume 20% of our energy budget. Beyond certain points, cost may outweigh benefits. Environmental requirements. Perhaps Earth-specific conditions, seasonal variations from axial tilt, large moon causing tides, complex climate cycles, were uniquely suited to driving intelligence evolution. Venus's slow rotation, potential lack of large moon, and possibly more stable climate might not have provided the same pressures. Estimate. P. Intelligence, Josh's life. 0.010.2. Low to moderate probability. This is the most uncertain factor. Intelligence might be inevitable given enough time, or it might be extraordinarily rare, a cosmic fluke that happened once on Earth and nowhere else in our solar system. P. Civilization, intelligence. Did technological civilization develop? If intelligent life evolved on Venus, would it develop civilization? Organized societies with culture, technology, agriculture, cities? On Earth, once humans, Homo sapiens, evolved, technological civilization developed relatively quickly. Agriculture within 100,000 years of modern humans emerging, writing within 5,000 years of agriculture, industrial technology within 5,000 years of writing, spaceflight within 100 years of industrial revolution. But did this require specific conditions? Social species. Civilization requires cooperation. Solitary intelligent species might not build cities. Tool use. Physical ability to manipulate environment. Hands, tentacles. If Venus's intelligent species were aquatic without manipulative appendages, technology might not develop. Resources. Access to metals for tools, fuel for fire, Earth's wood, coal, oil, materials for construction. Motivation, curiosity, desire to understand environment, competitive pressure with other groups. If intelligence evolves, civilization seems somewhat likely, say 20-80% probability, because intelligence exists precisely because it confers problem-solving advantages. And civilization is the ultimate application of intelligence to solving survival challenges through cooperation and technology. Estimate. P. Civilization. Intelligence. Sample source 0.2, 0.8. P. Survival long enough to matter. Did they exist long enough to leave detectable traces? This is where Venus's habitability timeline becomes crucial. Even if civilization arose, how long did it last? Scenarios. Brief existence, 1 million years. Civilization arises near the end of Venus's habitable period, doesn't have time to achieve space capability before conditions deteriorate. They go extinct, leaving minimal traces that are later obliterated by resurfacing. Moderate existence, there are 1,100 million years. Civilization exists long enough to achieve advanced technology. They might predict Venus's coming uninhabitability and either migrate to Earth, if capable of space travel, or retreat to protected environments, underground, floating cities in upper atmosphere, or go extinct. Traces might survive in protected locations. Long existence, 100+ million years. Highly advanced civilization persists through much of Venus's habitable period, possibly adapting as conditions worsen, eventually either transcending physical limitations, uploading consciousness, becoming energy beings, highly speculative, or successfully migrating to Earth or elsewhere. Estimate. Hard to quantify, but if civilization arose, probability of lasting at least 1 million years, long enough to potentially achieve space travel and leave significant technological signatures, might be 0.3-7. Combining probabilities, P. Venusian civilization, Chatchern P. life, X. P. intelligence, life, X. P. civilization and intelligence, X. P. survival. Conservative estimate, 0.5, 0.01, 0.2x, 0.3, 0.3, 0.03%. Moderate estimate, 0.7, 0.1, 0.5, 0.5, 0.05, 1.75%. Optimistic estimate, 0.9, 0.2, 0.8, 0.7, 0.8, 10%. So depending on assumptions, the probability of a technological civilization having existed on ancient Venus ranges from nearly impossible, 0.03%, to reasonably plausible, 10%. For comparison, Drake's original estimates for civilizations in the galaxy ranged from Tanshur 1 to tens of millions, showing similarly vast uncertainty. The key takeaway: while we can't prove Venusian civilization existed, we also can't dismiss it as impossible. Given Venus's long habitable period, it falls within the realm of possibility. Low probability perhaps, but non-zero. And non-zero probability of an alien civilization on our neighboring planet is profound enough to warrant serious investigation. The catastrophe. What happened to Venus? If Venus was indeed habitable for billions of years, What caused the transformation to its current hellish state? And if a civilization existed, what would they have experienced as their world died? The runaway greenhouse effect. The fundamental process is understood. Venus experienced runaway greenhouse warming, where positive feedbacks accelerated temperature increase until equilibrium was reached at current conditions. The sequence: initial warming. As the sun brightened over billions of years, Venus received increasing solar radiation. Additionally, volcanic outgassing added CO2 to the atmosphere. Ocean evaporation. Increased temperature caused ocean evaporation, adding water vapor, a potent greenhouse gas, to the atmosphere, trapping more heat, causing more evaporation. Positive feedback. Cloud feedback. Increased water vapor created more clouds. Initially, clouds might have provided negative feedback, reflecting sunlight, cooling the planet, but eventually, the greenhouse effect of water vapor overwhelmed cloud cooling. Water loss. With large amounts of water vapor in the upper atmosphere, solar UV radiation broke H2O into hydrogen and oxygen. Hydrogen, being light, escaped to space. Oxygen reacted with surface rocks. The water was permanently lost. CO2 accumulation. Without oceans to dissolve CO2 and without water to drive weathering processes that create carbonate rocks, Earth's mechanism for sequestering atmospheric carbon, CO2 from volcanic outgassing, accumulated in the atmosphere. Carbonate decomposition. As temperature increased, any existing carbonate rocks, limestone-like minerals that had sequestered carbon, thermally decomposed, releasing their CO2 back to the atmosphere. Another positive feedback. Equilibrium. Eventually, the greenhouse effect reached equilibrium when outgoing infrared radiation balanced incoming solar radiation at the current temperature of Ramarier 4622 degrees Celsius. Surface water completely gone, CO2 dominated atmosphere at 92 bars pressure. No mechanism to remove atmospheric CO2. The timeline question: when did this occur? Was it gradual over billions of years or catastrophically rapid? Evidence suggests a combination. Gradual phase, 4 toward 1 billion years ago. Slow increase in solar luminosity and gradual water loss over billions of years. Venus might have remained habitable, but became progressively warmer and drier. Catastrophic phase, 700 million years ago. The global resurfacing event, dated to 700 million years ago, based on crater counts, might coincide with the final runaway phase. Massive volcanic activity could have released enormous amounts of CO2 rapidly, triggering the final runaway greenhouse. Alternatively, the loss of the last oceans could have triggered it, with resurfacing being a consequence rather than cause. The catastrophe from a civilization's perspective. Imagine you're a Venusian scientist 750 million years ago. Your civilization has existed for hundreds of millions of years, achieving advanced technology and science. You understand your planet's climate system. And you're watching it deteriorate. Early warnings, millions of years before catastrophe. Oceans are slowly shrinking. Sea levels drop. Former ports become inland cities. Climate is warming. Polar regions become temperate. Temperate regions become hot storms, intensify. More energy in the atmosphere drives more violent weather. Droughts become more frequent in equatorial regions. Crisis stage, 100,000s to millions of years before end. Oceans evaporating rapidly. Coastlines receding, meters per year. Humidity increases to unbearable levels. Massive water vapor in atmosphere. Surface water disappearing. Rivers drying up. Lakes evaporating. Agriculture failing. Crops can't survive increasing heat. Mass migrations toward poles and high elevations where temperatures remain tolerable. Civilization under extreme stress. Resource wars. Societal collapse. Desperate technological attempts to reverse climate change. Final stage, thousands to hundreds of thousands of years. No liquid surface water remains, only water vapor in dense atmosphere. Temperature rising beyond biological tolerance. Even extremophiles dying. Cloud layers thickening, blocking sunlight. Surface in perpetual dim twilight. Atmospheric pressure increasing as CO2 outgasses from warming rocks, civilization faces extinction. Cannot survive on surface options. Retreat underground, if technology permits. Build sealed habitats. Migrate to another planet, Earth, or perish civilizational responses. What might a Venusian civilization have done facing inevitable doom? Option 1. Climate engineering. They might have attempted geoengineering projects to save their world. Solar shades, orbiting mirrors or dust clouds to reflect sunlight. Atmospheric processing, chemical or biological methods to remove CO2 orbital adjustment. Moving Venus farther from Sun. Requires technology far beyond current human capability, but might be possible for a very advanced civilization. Water import. Redirecting comets to replenish water lost to space. If they tried these and succeeded, Venus might still be habitable. Our timeline's Venus could be the result of unsuccessful or abandoned geoengineering. If they tried and failed, they'd know they were watching their world die, and nothing could stop it. Option 2. Adaptation underground cities. Retreating kilometers below surface, where temperature remains tolerable. Accessing geothermal energy and underground water, surviving as subterranean civilization. Atmospheric habitats. Building floating cities in upper atmosphere, where temperature and pressure are more moderate. At 50-60 kilometer altitude, Venus's atmosphere has Earth-like pressure and temperature 0-50 degrees C. Biological engineering, modifying themselves to survive higher temperatures, lower oxygen, higher pressure, becoming post-biological through cybernetic enhancement or consciousness uploading. Option 3. Evacuation. If they achieved space travel, they might have evacuated to another planet. The obvious destination, Earth. 700 million years ago, Earth was in the Cryogenian period, the middle of the Snowball Earth episodes, where glaciers extended to equator. Earth's climate was harsh by modern standards, but compared to dying Venus, it would have been paradise. Liquid water, breathable atmosphere, though low oxygen by modern standards. Habitability. Could Venusians have migrated to Earth? Technically feasible. Transfer from Venus to Earth requires Dasher 3.55 km s delta V, achievable with chemical rockets. Biologically challenging, Venusians adapted to their native biology, might not survive Earth's environment without life support or adaptation. Evidence. If Venusians came to Earth, where's the evidence? We'll explore this shortly. Option 4. Transcendence or extinction. Transcendence. A civilization lasting hundreds of millions of years might develop technologies we can't imagine, uploading consciousness to non-biological substrates, existing as pure energy or information, ascending to higher dimensions. They might have left physical reality entirely. Extinction. Most likely outcome. They simply died as their planet became uninhabitable, leaving ruins that were later obliterated by volcanism and weathering. The resurfacing event. The catastrophic resurfacing. 300 to 700 million years ago might be the key event. If massive volcanic activity covered Venus's entire surface with fresh lava, any surface structures, cities, monuments, artifacts would be buried under kilometers of basalt. Evidence of previous civilization might still exist underground, in orbit, or on preserved highland regions that escaped complete resurfacing, but surface traces would be obliterated. This presents a profound problem. If Venusian civilization existed and was destroyed by resurfacing, proving it becomes extraordinarily difficult. We'd be looking for needles in a haystack on a planet we've barely explored, where the haystack was melted and re-solidified 700 million years ago. Evidence on Venus. What might still exist? If an ancient civilization existed on Venus, what evidence might remain after 700 plus million years and catastrophic resurfacing? Let's examine possibilities systematically. Surface artifacts. Most surface structures would be destroyed, but some might survive. Highland regions. The tesserae, ancient, highly deformed highland terrains, predate the resurfacing event. If any surface structures were built on these highlands, they might survive buried under less lava than the lowland plains. Radar images of tesserae show complex, highly fractured terrain. Could some of this complexity be structural rather than purely geological? The problem: Magellan radar resolution was only 100, 200 meters. Small structures would be invisible. We need much higher resolution imaging to identify artificial structures among natural, geological chaos. Sheltered locations. Certain locations, deep valleys, cave systems, lava tubes, overhangs, might protect artifacts from complete burial. But with surface temperatures high enough to melt lead, organic materials and most metals would be destroyed. Only extremely durable materials, tungsten, ceramics, certain composites, would survive. Anomalous features. Some researchers have claimed to identify artificial-looking structures in Magellan radar images, straight lines and geometric shapes. Some features appear rectilinear, though these could be volcanic or tectonic. Symmetric formations. Certain crater-like features appear too regular, possibly artificial, though natural explanations exist. Collapsed structures. Some geological features resemble collapsed domes or buildings, though alternative geological interpretations are more accepted. These claims are controversial and generally dismissed by planetary scientists as pareidolia, seeing patterns where none exist, combined with insufficient resolution to make definitive claims. But they warrant follow-up with higher resolution missions. Subsurface artifacts. Buried structures might survive better than surface ones. Archaeological sites, cities, infrastructure, industrial facilities buried under volcanic plains might be detectable through ground-penetrating radar, from orbit or aerial platforms, mapping subsurface density variations. Gravitational anomalies. Buried massive structures might create subtle gravitational irregularities. Seismic surveys. Active or passive seismic studies could reveal hollow spaces, density discontinuities, deep underground facilities. If Venusians built underground cities or bunkers, these might survive, protected from surface resurfacing. Potentially still intact if constructed in geologically stable formations, might contain preserved artifacts, technology, possibly even data storage devices. Challenges. Accessing subsurface structures requires drilling or excavation, extremely difficult given Venus's conditions. Robotic systems capable of drilling through kilometers of rock in 462 degrees heat and 92 bar pressure are at the edge of current technology. Orbital artifacts, space infrastructure might be the most durable evidence. Satellites. If Venusians achieved space capability, satellites placed in Venus orbit could still exist. Long-term survival. In vacuum, satellites could persist for billions of years without atmospheric drag or significant weathering detectability. Radar or optical surveys from Earth or from missions to Venus could detect defunct satellites. Protection. Micrometeorite damage would accumulate, but wouldn't completely destroy metallic structures. Space stations. Larger structures in orbit would be even more detectable and durable. Lagrange points. Objects placed at Venus, Sun. Lagrange points, gravitationally stable locations, would remain there indefinitely unless perturbed. Search status. We haven't systematically searched Venus's orbital space for artificial objects. Dedicated survey missions could reveal surprises. Artifacts on other bodies. Venusians might have left artifacts elsewhere in the solar system. Mercury, close to Venus, might have been explored or utilized for resources. Mercury's slow rotation and extreme temperatures make it less habitable than ancient Venus, but potentially useful for solar energy collection or mining. Earth's moon. If Venusians visited Earth, they might have stopped at the moon. Artifacts in lunar lava tubes or buried under regolith could survive billions of years. Asteroids. Mining operations on asteroids would leave altered structures, modified orbits, or artifacts. Mars. Though farther, Mars was warmer and wetter billions of years ago and might have attracted Venusian attention. Cometary Chauch asteroid impacts. Venusian materials could have been ejected from Venus by asteroid impacts and delivered to Earth or other bodies. Essentially, Venusian panspermia of artifacts rather than life. Atmospheric anomalies. Current Venus atmosphere might contain clues. Chemical signatures. Industrial activity leaves chemical markers. On Earth, our industrial revolution has altered atmospheric composition. CO2 increase, synthetic chemicals, radioactive isotopes from nuclear testing. Ancient Venusian industry might have left long-lived isotopic or chemical signatures, though most would be destroyed by geological recycling over hundreds of millions of years. Phosphine detection. In 2020, scientists claimed to detect phosphine, pH3, in Venus's atmosphere, sparking controversy. Phosphine is produced by life on Earth, anaerobically by microbes, and isn't easily produced by known abiotic processes. The detection is disputed, but if confirmed, it might indicate current microbial life in Venus's clouds, remnant biological processes from ancient biosphere, industrial contamination from ancient civilization. Phosphine is used in various industrial processes, atmospheric life. If ancient Venus had life, some microbes might have adapted to survive in the cloud layers as their planet's surface became uninhabitable. Venus's clouds at 50-60 kilometers altitude have temperatures and pressures compatible with Earth life. Microbes might persist there, descendants of ancient Venusian biosphere, or even of ancient Venusian civilization's biological or biotechnology components. Magnetic field evidence. Though Venus has no global magnetic field, localized magnetic anomalies might preserve information. Remnant magnetism. Rocks can preserve magnetic fields from when they cooled. If ancient Venus had a magnetic field, when it rotated faster, rocks from that era would retain magnetic signatures. Analysis of rock magnetism could reveal whether Venus once had a dynamo-generated field. When it disappeared, possibly related to catastrophe timing. Whether any magnetic anomalies are artificial, metallic artifacts might create localized magnetic fields. Future missions. Magnetometers on future landers could detect and map magnetic anomalies, identifying unusual patterns that might indicate buried metallic structures. Isotopic evidence. Nuclear technology leaves long-lasting isotopic signatures. Radioactive isotopes. If Venusians used nuclear power or weapons, certain isotopes would be produced. Plutonium-244, half-life 80 million years. Isotopes from 700 million years ago would be detectable. Plutonium-239, half-life 24,000 years, too short to survive. Certain fission products, some have million-year half-lives. Search method, spectrographic analysis of Venus's surface or atmospheric samples, looking for isotopic ratios inconsistent with natural processes. Challenge, distinguishing ancient artificial isotopes from natural ones produced by cosmic rays or natural radioactive decay requires sophisticated analysis. Technosignatures. Besides physical artifacts, technological activity might leave detectable signatures. Modified orbital bodies. If Venusians mined asteroids, moved spacecraft, or altered orbital mechanics, the solar system's small body population might show anomalies. Objects in unlikely orbits, depleted resources in certain asteroids, artificial objects in unusual locations. Electromagnetic remnants. Ancient radio transmissions would have propagated into space at the speed of light. Transmissions from 700 million years ago would now be 700 million light years away, far too distant and weak to detect. But ancient technological activity might have left electromagnetic signatures in Venus's environment, anomalous ionization, radiation patterns, though these would be extremely difficult to detect after such time. Geological signatures. Large-scale industrial activity might leave geological evidence. Mining, altered mountain profiles, extracted veins, tailings. Construction, modified landscapes, quarries, canals. Nuclear, craters from weapons or accidents, vitrified soil. The burden of proof. Proving Venusian civilization existed requires extraordinary evidence, clear, unambiguous signatures that couldn't result from natural processes. This is extremely challenging given limited data about Venus's surface, only low-resolution radar maps and a few lander images, catastrophic resurfacing obliterating surface evidence, extreme conditions preventing easy exploration, natural geological processes that can mimic artificial structures. However, absence of evidence isn't evidence of absence. We haven't looked thoroughly enough to rule out Venusian civilization. The next generation of Venus missions might provide clearer answers. Evidence on Earth. Did Venusians come here? If ancient Venusians achieved space travel and their planet was becoming uninhabitable, Earth would be the logical refuge. Could there be evidence on Earth of Venusian visitation or colonization? Timeline considerations. The Venusian catastrophe likely occurred 300 to 700 million years ago. Earth's history during this period, 700 million years ago. Cryogenian period, snowball Earth glaciations, continents clustered, ice extending to equator, harsh climate but habitable. Life exists, but is mostly simple multicellular organisms and microbes, no complex animals yet. 600 million years ago. Ediacaran period, ice ages ending, first complex multicellular organisms appearing, Ediacaran biota, oxygen levels rising. 541 million years ago. Cambrian explosion, sudden diversification of complex animal life, most major animal phyla appearing within 10 to 20 million years. This timeline is intriguing. The Cambrian explosion occurs roughly 100 or 200 million years after the likely Venusian catastrophe. Is this coincidence or connection? Hypothetical Venusian migration to Earth. If Venusians came to Earth, what would we expect? Scenario 1. Direct colonization. Venusians establish colonies on Earth, bringing their technology, biology, and civilization. Expected evidence. Anatomical. Fossils of organisms with no evolutionary predecessors on Earth appearing suddenly in the fossil record. Technological. Artifacts, structures. Tools from 600 to 700 million years ago in sedimentary layers. Genetic. Earth life showing genetic engineering signatures or containing genes with no evolutionary pathway on Earth. Isotopic. Biological materials with isotopic ratios matching Venus rather than Earth-observed evidence. We don't see clear examples of any of these. The Cambrian explosion shows sudden diversification, but the organisms are clearly related to earlier Earth life. They have evolutionary precursors in the Ediacaran and before. We haven't found obvious technological artifacts in Cambrian or pre-Cambrian strata. However, the Cambrian explosion is genuinely puzzling. Why did complex life suddenly diversify after 3+ billion years of simple forms? Standard explanations include rising oxygen levels enabling complex metabolism, evolution of predation driving arms races, development of genetic regulatory systems, Hox genes, allowing body plan diversification, environmental changes after ice ages. But could external influence have played a role? Might Venusians have introduced genetic material, organisms, or technology that accelerated Earth's biological evolution? Scenario 2. Panspermia. Rather than direct colonization, Venusians might have transferred microbial life. Mechanisms? Natural panspermia? Microbes surviving in meteorites ejected from Venus by impacts, traveling to Earth, seeding life. Directed panspermia. Deliberately sending microbes or genetic material to Earth to seed or augment Earth's biosphere. Expected evidence. Early Earth life, showing genetic connections to hypothetical Venus life. Sudden appearance of new metabolic pathways or genetic systems without clear Earth evolutionary history. Observed evidence. Earth's genetic code is universal across all life, suggesting single origin. Either life arose once on Earth or all Earth life descends from a single panspermia event so early that all separate lineages went extinct. If Venusian microbes arrived after Earth life was already established, we'd expect to find organisms with different genetic codes or biochemistry. We don't see this, suggesting either. Life only arose once, on Earth or Venus, then transferred. Venusian life and Earth life had common origin. Earlier panspermia from another source. Venusian life arrived so early, it became the exclusive ancestor of all subsequent life. Scenario 3. Technology transfer. Venusians might have visited Earth without colonizing it, leaving artifacts or influencing early human ancestors. Problem: 600 to 700 million years ago, no humans or even vertebrates existed on land. The first land vertebrates, tetrapods, appeared about 375 million years ago. Mammals, much later. Primates, about 65 million years ago. Hominids, about 6 million years ago. Humans, Homo sapiens, only 300,000 years ago. If Venusians came to Earth during their civilization's crisis period, they'd find a world with no intelligent recipients for their knowledge. They could leave artifacts or messages for future intelligent species to discover genetically engineer Earth organisms to accelerate the evolution of intelligence, highly speculative. Establish long-term monitoring stations that remain until intelligence evolved. Simply explore and then return to Venus, or go extinct ancient artifacts on Earth. Could there be Venusian artifacts on Earth from 600 plus million years ago? Challenges. Erosion. Most of Earth's surface has been recycled. Plate tectonics subducts crust. Mountain building and erosion destroy landscapes. Weathering breaks down materials. Sedimentation. Artifacts would be buried under hundreds of meters of sediment, deposited over hundreds of millions of years. Geological activity, metamorphism, volcanism, continental drift, all destroy or alter structures and artifacts. Where might artifacts survive? Geologically stable cratons, ancient continental cores, Canadian shield, Australian cratons, African cratons, that haven't been significantly deformed for billions of years. Deep ocean sediments, least disturbed sediments, but also least explored Antarctic ice. Anything under miles of ice is preserved, but inaccessible and unlikely to be found. Lunar deposits, artifacts left on Moon during Venusian visits, would survive indefinitely. Search status, we haven't systematically searched ancient geological formations for artificial materials from 600 million years ago. Any such search would require knowing what to look for and where. Extremely difficult. Ancient anomalies. Some controversial claims of ancient artifacts or out-of-place objects exist. Grooved spheres, South Africa. Spheres found in 2.8 billion-year-old rock with grooves that some claim are artificial. Geologists conclude these are natural concretions. Coso artifact, California. Object found in 1961 in rock allegedly 500,000 years old, containing what appeared to be a spark plug. Later analysis suggested it was a 1920s spark plug in recent rock, not an ancient artifact. Ancient screws and nails, occasional claims of metal objects found in ancient rock formations. Most are hoaxes, misidentifications, or modern contamination. These claims don't withstand scrutiny, but they illustrate human tendency to look for ancient anomalies. If Venusian artifacts existed, they might be misinterpreted as geological oddities or never recognized as artificial. Genetic evidence. Could Venusian genetic engineering explain anything about Earth life? Cambrian explosion revisited. The rapid diversification of body plans could theoretically be explained by genetic engineering, introducing regulatory genes that allow more complex developmental programs. But we can trace the evolutionary development of these genes, Hox genes, etc., in earlier organisms. The Cambrian animals are clearly related to Precambrian life, not separate insertions. Genetic analysis shows continuous evolutionary relationships. Viral insertions. Earth genomes contain sequences from ancient viral infections, endogenous retroviruses. Could some be of Venusian origin? Distinguishing ancient viral sequences from Venusian bioengineering versus natural Earth viruses would be nearly impossible without comparison to actual Venusian genetic material. Non-standard codons. All Earth life uses the same genetic code with minor variations. If Venusian life used a different code and genetically engineered Earth organisms, we might see organisms with two genetic codes operating simultaneously. We don't observe this. Conclusion. No clear genetic evidence of Venusian influence, but subtle engineering might be undetectable or misinterpreted as natural evolution. Mythological and cultural evidence. Could human mythology preserve memories of ancient Venusian contact? Venus in mythology. Venus, the planet, features prominently in many ancient cultures. Venus as deity. Venus personified as goddess of love. Roman Venus, Greek Aphrodite, Mesopotamian Ishtar, Inanna. But these associations are relatively recent, last few thousand years, and clearly mythological, not technological contact. Venus as morning star and evening star. Many cultures observed Venus as the brightest object in sky after sun and moon, appearing as both morning and evening star. Catastrophe myths. Some comparative mythologists, Immanuel Velikovsky, controversial and generally dismissed by mainstream scholars, claimed ancient. Myths describe Venus as a comet that disrupted other planets and Earth in historical times. Mainstream scholarship rejects these claims as pseudoscience, but they reflect human tendency to associate Venus with celestial drama. Dragons and serpents. Could mythological sky serpents or dragons represent memories of Venusian spacecraft? This is pure speculation without supporting evidence, but it's theoretically possible that extremely ancient human oral traditions, going back millions of years, might preserve distorted memories of encounters with non-human intelligence. However, oral traditions don't reliably preserve information over more than a few thousand years. Without writing 600 million years ago, humans didn't exist. Dragon myths likely have more mundane explanations. Dinosaur fossils, fear of snakes and predators, symbolic representations of chaos. Underwater structures. Some alternative researchers claim underwater structures, Bimini Road, Yonaguni Monument, others, are artificial and ancient. Most geologists consider these natural formations. Even if some were artificial, dating them to millions of years ago is not supported by evidence. Most claims are for thousands of years, not hundreds of millions. Conclusion on Earth. Evidence. There's no conclusive evidence of Venusian visitation or colonization of Earth. However, we haven't looked systematically in the right time period, 600 and 700 million years ago. Geological processes would destroy most evidence. We might not recognize highly degraded ancient artifacts. Genetic or biological influences might be subtle and misinterpreted as natural evolution. The absence of clear evidence doesn't prove Venusians never came to Earth. It might just mean evidence is extremely hard to find or has been destroyed by geological time. The Moon, ancient witness and possible archive. Earth's moon might be the best place to search for evidence of ancient Venusian civilization, for several compelling reasons. Advantages of the moon. No atmosphere. Artifacts on the moon aren't weathered by wind, rain, or oxidation. Materials persist indefinitely in lunar vacuum. No plate tectonics. The moon's surface is geologically dead. No subduction, mountain building, or continental drift to destroy or bury structures. Minimal erosion. Only micrometeorite bombardment and rare large impacts disturb the surface. Erosion rates are millions of times slower than Earth's. Accessible. The moon is humanity's most accessible extraterrestrial body. We've already sent dozens of missions, and even humans. Comprehensive surveys are technically feasible. Long-term preservation. Artifacts placed on the moon. Billions of years ago could still exist, virtually unchanged, on the surface or in lava tubes and craters. Evidence to look for. Surface artifacts. If Venusians visited the moon, they might have left. Landing sites, modified regolith from rocket exhaust, landing pads, base foundations, equipment, abandoned tools, instruments, rovers, habitation modules, markers, monuments, messages, information caches, search status. We've photographed the moon's surface at high resolution from orbit. Lunar Reconnaissance Orbiter can resolve objects Darshanam 50 kilometers across. But we've only examined a tiny fraction closely enough to identify artificial structures that aren't ours. Most searches focus on Apollo landing sites and preparing for future missions, not looking for ancient alien artifacts. Systematic searches. A dedicated survey looking for anomalous reflectivity, geometry, or composition could reveal non-natural objects. Machine learning algorithms could analyze millions of images for unusual features. Lava tubes. The moon has extensive lava tube networks. Hollow tubes formed when lava flows cooled on the surface, while molten lava continued flowing underneath, then drained, leaving empty tunnels. Advantages for artifact preservation. Protected from micrometeorite bombardment. Stable temperature, unlike surface, day, night extremes. Shielded from cosmic radiation, hidden from orbital observation. Venusian use. If Venusians wanted to establish permanent moon bases or cache information for future discovery, lava tubes would be ideal locations. Artifacts inside tubes could survive indefinitely. Exploration status. We've discovered over 200 lunar lava tube openings, called pits, from orbital imaging. Some tubes are enormous, potentially 100 plus meters in diameter, kilometers long, large enough to hold cities. But none have been explored internally. Future missions, NASA's Artemis program, commercial missions, plan to explore some tubes, primarily for establishing human bases, but could search for ancient artifacts simultaneously. Subsurface regolith. The lunar regolith, surface dust and rock layer, accumulates gradually from micrometeorite impacts. Deeper regolith is older. Artifact burial, objects on the moon's surface. 700 million years ago would be buried under centimeters to meters of regolith accumulated since. Drilling or excavation could uncover them. Dating. Regolith layers can be dated through various techniques: cosmic ray exposure ages, isotopic analysis. If artifacts are found at specific depths, their age can be estimated from surrounding regolith. Lunar polar craters. Certain polar craters are permanently shadowed. Sunlight never reaches their interiors. These craters are extremely cold, down to 30-40 Kelvin, 240 degrees, and contain water ice delivered by comets. Advantages. Extreme preservation. Materials don't degrade water ice useful for future missions, and possibly for ancient Venusians, might have attracted Venusian attention as resource site search status. We've mapped polar craters from orbit and detected water ice through radar and spectrographic analysis, but interiors haven't been explored. Physically, future missions plan to investigate for water resources, could simultaneously search for artifacts. Lunar orbit. Objects in lunar orbit would remain indefinitely unless hit by debris or pulled down by Earth's gravity over millions of years. Satellites in certain stable lunar orbits, particularly polar orbits and some distant prograde orbits, could persist for billions of years. Search. We've cataloged large debris in lunar orbit, Apollo mission remnants, crashed orbiters, but haven't systematically searched for small objects that might be ancient artificial satellites. Earth-Moon Lagrange points. The Earth-Moon system has 5 Lagrange points, locations where gravitational forces balance, creating stable positions for objects. L4 and L5, located 60 degrees ahead and behind the Moon in its orbit around Earth. These are particularly stable. Objects placed there could remain for millions or billions of years with minimal perturbation. Venusian use, ideal for placing long-term message capsules, monitoring stations, or resource caches. Search status. We've discovered natural dust clouds at Earth-Moon L4 and L5, Kordylewski clouds, but haven't found artificial objects. Dedicated surveys with appropriate sensors could detect artificial objects if they exist. Information caches. If Venusians wanted to preserve their knowledge for future discovery, where and how might they do it? Medium. Physical inscriptions. Carved in rock. Virtually indestructible but limited information capacity. Metal plaques. Durable if using appropriate metals. Tungsten, iridium. Can hold more complex engravings or symbolic information. Crystal data storage. Quartz or sapphire can store information encoded in lattice defects or optical properties, potentially lasting billions of years. Engineered isotopes. Information could theoretically be encoded in arrangements of radioactive isotopes, though this would be extremely advanced technology. Location, prominent features, near large craters or mountain peaks that would be obvious exploration targets. Protected locations, inside lava tubes or buried at known depths. Multiple redundancy, same message in many locations to ensure discovery. Content, visual symbols, mathematics, physics diagrams, chemistry, universal languages, maps, showing Venus, Earth, solar system, identifying their origin. Warning, describing what happened to Venus, possibly warning Earth not to follow same path. History, records of their civilization, culture, knowledge. The search we haven't conducted. Despite decades of lunar exploration, we've never systematically searched for ancient alien artifacts on the moon. Every mission has had specific goals: mapping, sample return. Apollo missions focused on beating USSR to the moon, not archaeology. A dedicated search would require high-resolution surface imaging survey, better than current, lava tube exploration, robotic or human missions, excavation of regolith at various depths in multiple locations, survey of lunar orbital space and Lagrange points, spectral analysis searching for unusual material signatures. Cost would be substantial, but not prohibitive, perhaps comparable to a flagship planetary science mission, $1 to $2 billion. The question is whether funding agencies and scientists would support such a speculative search. However, as lunar exploration expands, NASA's Artemis program, commercial missions, international competition for lunar resources, will naturally explore more of the moon. If Venusian artifacts exist, they might be found incidentally during routine exploration. The moon is our best archive for ancient solar system history. Geological samples from billions of years ago remain pristine on the surface. Asteroid impact history is recorded in craters. Solar wind particles are preserved in regolith. If intelligent Venusians existed 700 million years ago, the moon might be the only place their legacy remains intact, waiting for someone to look carefully enough to find it. Alternative scenarios. What if they survived? We've assumed Venusian civilization either went extinct or evacuated as their planet became uninhabitable. But what if some survived, adapting to Venus's changing conditions or finding refuge in protected environments? Scenario 1. Atmospheric Venusians. Venus's atmosphere at 50 to 60 kilometers altitude has Earth-like pressure, bar 1 bar, and temperature, 50 degrees Celsius. Could Venusians have built floating cities in the cloud layer, abandoning the surface as it became uninhabitable? Feasibility. Physics. Floating habitats in Venus's atmosphere are entirely feasible. The thick CO2 atmosphere is so dense that structures filled with breathable air, N2O2 mix, would naturally float, like hot air balloons on Earth but requiring no heating. Resources. Carbon, from atmospheric CO2, hydrogen, if any remains, sulfur, from clouds, and trace elements could be extracted from atmosphere or occasional surface mining expeditions. Energy. Solar panels would work excellently above the clouds where sunlight is continuous and intense. Agriculture. Photosynthesis-based food production in transparent habitats. Evidence. Atmospheric anomalies. If floating cities exist, they might create detectable signatures, unusual albedo features, electromagnetic emissions, chemical anomalies. Phosphine. The controversial phosphine detection could indicate biological activity in clouds, remnants of ancient biosphere or agriculture from floating civilization. Balloon probes. Future Venus missions plan to send balloon probes to cruise through the cloud layer. These could detect structures, though recognizing them as artificial versus natural features would be challenging. Likelihood. Floating cities are physically plausible and have been proposed for human colonization of Venus. If Venusians achieved sufficient technology, this could be their survival strategy. However, maintaining a technological civilization in balloon cities for 700 million years seems improbable. Resource limitations, isolation, technological decay, genetic drift, eventual extinction seem more likely, but a remnant population might persist. Communication. If they exist and are technologically capable, they might attempt communication. We should listen for radio signals from Venus. To date, no systematic SETI effort has focused on Venus, assuming it uninhabitable, but this might be premature. Scenario 2. Underground Venusians. Instead of floating cities, Venusians might have retreated underground where temperature is lower. Depth versus temperature. Venus's surface is 462 degrees Celsius. Temperature increases with depth due to geothermal gradient, but also increases with altitude in the lower atmosphere. There might be a Goldilocks depth where temperature is tolerable. Calculations suggest that a few kilometers underground, where pressure is higher but temperature hasn't increased as much as the geothermal gradient would predict, due to complex thermal dynamics, conditions might be marginally survivable for extremely heat-tolerant organisms, or with technology. Requirements: cooling systems, active cooling using circulating fluids or heat pumps. Power: geothermal energy, abundant on Venus, or nuclear if they have it. Life support: sealed habitats, oxygen generation, food production through chemosynthesis or hydroponics mining, extracting water, if any exists, deep underground in hydrated minerals, and other resources. Evidence: seismic activity. Unexplained seismic events might indicate underground activity, though volcanic tectonic activity is sufficient explanation. Subsurface anomalies. Radar or gravitational surveys might detect voids or structures. Surface access points. Entrances to underground facilities might be detectable as unusual surface features. Likelihood more plausible than floating cities for long-term survival. Underground environments protect from worst surface conditions and provide access to minerals and geothermal energy. A civilization determined to survive could potentially maintain underground existence indefinitely. Contact. If they exist, they're likely unaware of us, unless they have surface monitoring equipment still functional. Direct contact would require surface missions detecting underground structures and attempting communication. Scenario 3. Departure. Venusians might have left Venus entirely, not for Earth but for elsewhere in the solar system or beyond. Destinations: interstellar space. If they achieved interstellar travel, they might have left the solar system entirely, seeking habitable exoplanets. We'd never find evidence unless they left messages for future civilizations. Outer solar system: moons of Jupiter or Saturn, Ganymede, Callisto, Titan, Enceladus might offer habitable subsurface environments. These moons have ice shells over liquid water oceans, potentially habitable with technology. Artificial habitats: O'Neill cylinders, generation ships, artificial worldlets constructed from asteroid materials, providing Earth-like conditions indefinitely, independent of planetary surfaces. Digital existence: upload consciousness to non-biological substrates, exist as digital entities on spacecraft, moon bases, or distributed through solar system. Evidence: we'd find this evidence through outer solar system exploration. Anomalies on moons, structures, modified surfaces, artifacts would indicate non-human intelligence. We've explored these moons very little, a few flybys and one mission, Cassini, studying Saturn's system for 13 years. Comprehensive surveys might reveal surprises. Scenario 4. Transcendence. A civilization lasting hundreds of millions of years might develop in directions we can't imagine. Consciousness upload, transferring minds to digital, crystalline, quantum substrates, becoming non-biological energy beings. Converting physical form into patterns of energy or fields, highly speculative, unknown physics. Higher dimensions. Accessing spatial or temporal dimensions beyond our 3+1. Existing in a domain we can't perceive integration with environment. Merging with Venus's geology or atmosphere, becoming planetary scale consciousness. Evidence. By definition, transcendence would make them undetectable or unrecognizable to us. We might interact with them without knowing. Scenario 5. They're here. What if Venusians came to Earth and are still here, hidden or integrated? Underground Earth. Just as they might hide underground on Venus, they might have underground cities on Earth, in deep caves, beneath oceans, or excavated facilities in stable geology. The hollow Earth and inner Earth theories that we explored earlier might not be about prehistoric humans, but about Venusian refugees. Disguise. If they're biologically compatible or use advanced technology, they might live among humans undetected, either physically disguised or in hidden communities. Antarctic ocean bases, remote locations, Antarctica, deep ocean trenches, remote mountains, could hide bases. These regions are barely explored and could conceal structures. Likelihood, low. If Venusians arrived on Earth, they'd either have died out, no technological infrastructure we've found, integrated with Earth's evolutionary process, becoming ancestors of modern life, but genetic evidence doesn't support separate origin. Remain hidden. Requires explaining why they haven't made contact despite human technological development, making us potential peers. Occam's razor. The simplest explanation for absence of evidence is absence. They either never existed, went extinct, or left the solar system. Hidden survival requires many additional assumptions, but absence of evidence is not evidence of absence, especially for phenomena deliberately hiding. We should remain open to surprising discoveries. The scientific case. Research program for investigation. If we take the Venusian civilization hypothesis seriously, what scientific research program should we pursue? Let's outline investigations that could provide evidence for or against the hypothesis. Phase 1. Orbital reconnaissance, current technology. High-resolution radar. Mapping. Objective. Create complete radar map of Venus at 10-meter resolution. Current Magellan data is 100-200 meter. Method. Synthetic aperture radar from orbit optimized for surface mapping. Target anomalies. Geometric patterns. Rectilinear features. Symmetric structures. Unusual albedo. Subsurface density variations. Timeline. 2-3-year mission in Venus orbit. Cost. 1 to 2 billion. Comparable to Mars Reconnaissance Orbiter. Atmospheric composition. Analysis. Objective. Comprehensive atmospheric chemistry, including trace gases, isotopic ratios, vertical profiles. Method. Orbital spectrometers, atmospheric probes, balloon platforms. Target. Anomalies, industrial chemicals, unusual isotopic ratios, biosignatures, phosphine confirmed, localized chemical variations. Timeline. 3-5-year mission. Cost. $2-3 billion orbital artifact. Search. Objective. Survey Venus orbital space for artificial objects. Method. Optical and radar surveys from multiple angles. Mapping of Lagrange points. Timeline. 1-2 years. Cost. $500 million. Could piggyback on other Venus missions. Phase 2. Atmospheric exploration. Near-term technology. Balloon missions. Objective. Deploy multiple balloon platforms to cruise cloud layer, 50-60 kilometer altitude, for months to years. Method. Autonomous balloons with cameras, spectrometers, sampling equipment, life detection instruments. Targets. Floating structures, if any. Biological activity. Chemical anomalies. Detailed 3D mapping of cloud layer timeline. 2 to 3 years per mission. Deploy multiple balloons. Cost. $500 million per mission. Aerial drones. Objective. Heavier than air aircraft, similar to Mars helicopter but for Venus, to explore atmosphere and approach surface for close inspection. Method. Nuclear or solar-powered aircraft with cameras and sensors. Advantages. Can fly lower than balloons. Inspect surface features at closer range. Investigate targets of interest. Timeline. Demonstration mission. 1-2 years. Full mission. 3 to 5 years. Cost. 1 to 2 billion. Phase 3. Surface exploration. Advanced technology required. Long-duration landers. Objective. Landers that survive weeks to months on surface, versus current record of 127 minutes. Technology. Advanced cooling systems. High-temperature electronics. Silicon carbide semiconductors. Rugged construction instruments. Cameras, drills, seismometers, chemical analyzers, ground-penetrating, radar targets, tesserae regions, oldest terrain, anomalous features identified from orbit, potential archaeological sites. Timeline. Technology development. 5-10 years. Mission. 3 to 5 years. Cost. $3.5 billion per lander. Subsurface drilling. Objective. Drill several meters into surface at multiple sites to access buried materials. Method. Rotary or percussion drill. Refrigerated to protect equipment. Returning samples to lander for analysis. Target layers. Below resurface event depth. Sedimentary layers. Anomalous subsurface features. Timeline. 10-15 years. Technology plus mission. Cost. $7 billion seismic network. Objective: deploy network of seismometers across Venus to map internal structure and detect activity. Method: multiple long-duration landers with seismic instruments. Data: internal structure, active volcanism, possible subsurface voids or structures. Timeline: 5-10 years. Cost: now $4-6 billion for network. Phase 4, sample return. Future technology. Surface: sample return. Objective: collect surface samples and return to Earth for detailed analysis. Method: lander collects samples, stores in thermally protected capsule, launches to Venus orbit, rendezvous with return spacecraft, transfers samples to Earth return capsule, Earth entry and recovery analysis, isotopic dating, organic analysis, mineralogy, biosignature search, technosignature search, industrial materials, unusual isotopes. Timeline: 15 to 20 years, technology development plus mission. Cost: 8-10 billion, comparable to Mars sample return. Atmospheric sample return. Objective: collect atmospheric samples including cloud particles and return to Earth method. Balloon or aircraft collects samples at various altitudes, returns to orbit, transfers to Earth return vehicle analysis. Search for microorganisms, organic compounds, isotopic signatures, industrial chemicals. Timeline: 10 to 15 years. Cost: $3-5 billion phase. 5. Human exploration, long-term, crewed Venus, atmospheric mission. Objective: humans in orbit or atmospheric platforms exploring Venus. Method: habitats in Venus orbit or floating in atmosphere at 50 kilometers altitude, controlling robotic assets on surface, conducting hands-on investigation. Advantages: human judgment, adaptability, comprehensive survey. Timeline: 30-50 years. Technology plus infrastructure. Cost: 50-100 billion. Phase 6, lunar investigation, parallel track. Lunar artifact search. Objective: search Moon for Venusian artifacts. Method: high-resolution imaging survey, lava tube exploration, robotic and human, regolith excavation, polar crater exploration. Timeline: ongoing with Artemis program and commercial missions. Dedicated searches could accelerate cost. Leverages existing lunar exploration. Dedicated searches. $2.5 billion analysis and interpretation. Throughout this research program, international collaboration and open data sharing would be essential. Every image, every spectrum, every measurement should be publicly available for analysis by researchers worldwide. Machine learning and citizen science, volunteers examining images and data, could accelerate detection of anomalies. False positives. The main challenge is distinguishing natural features from potential artificial ones. Venus's geology creates shapes that can resemble artificial structures. Volcanic craters can look geometric. Tectonic features can create linear patterns. Erosion can produce symmetric shapes. Pareidolia, seeing patterns where none exist, affects humans and potentially AI trained on human-labeled data. Multiple independent lines of evidence would be required to confirm anything as artificial. A single anomalous image wouldn't suffice. We'd need correspondence with other data, radar, spectrographic, gravitational anomaly. Multiple occurrences. One strange feature could be natural coincidence. Many similar features in different locations suggest design. Characteristics inconsistent with natural processes. Unnatural materials. Impossible formations. Technological signatures. Positive results. If this research program finds clear evidence of ancient Venusian civilization, it would be the most profound discovery in human history, fundamentally altering our understanding of life, intelligence, and our place in the cosmos. Negative results. If comprehensive investigation finds no evidence, it wouldn't prove Venusian civilization never existed. Maybe evidence was completely destroyed or is in unexplored locations, but it would make the hypothesis less plausible. Science can't prove negatives definitively, but thorough negative results shift probability assessments. Current status. We're in the early stages of Phase 1. NASA's Veritas and Da Vinci missions, delayed to early 2030s, will provide better data than we currently have. ESA's Envision mission, late 2030s, will contribute. These missions weren't designed to search for ancient civilizations, but will provide data that could reveal anomalies if they exist. Private space companies and international competition, India, China, Russia, Japan, all have Venus mission plans, might accelerate Venus exploration. In 20 to 30 years, we might have sufficient data to make much stronger assessments of whether ancient Venusian civilization existed. Implications for human future. Whether or not Venusian civilization existed, contemplating the possibility has profound implications for humanity's future. The Venusian warning. If Venus was once habitable and became hell through runaway greenhouse effect, it stands as a cosmic cautionary tale about planetary climate. Earth's trajectory. Earth is experiencing anthropogenic climate change, human activities increasing atmospheric CO2, warming the planet, destabilizing climate systems. While current projections don't suggest Earth will become like Venus, we're not close to runaway greenhouse threshold. Venus demonstrates that planets can undergo catastrophic climate transitions from which there's no recovery. Lessons. Planetary atmospheres are fragile. The balance between habitable and uninhabitable can shift. Positive feedbacks are dangerous. Once certain thresholds are crossed, ocean evaporation, CO2 release from rocks, warming accelerates uncontrollably. Technology must outpace catastrophe. If Venusians couldn't stop their planet's transformation, despite presumably advanced technology, we should be very concerned about our own climate crisis. Backup plans matter. A single planet species is vulnerable. Venusians, if they existed, needed somewhere to go. So do we. Multi-planet species. The Venusian scenario motivates becoming a multi-planet species. Mars colonization. Establishing permanent human presence on Mars provides backup. If Earth faces catastrophe, humanity survives. O'Neill cylinders. Artificial space habitats provide Earth-like conditions independent of planetary surfaces, invulnerable to planetary climate change. Interstellar expansion. Eventually, escaping the solar system entirely protects against system-wide catastrophes, sun's evolution, stellar encounters, supernovae. Venus as testing ground. Ironically, if we learn to make Venus habitable again, terraforming, we'll have proven we can manage planetary atmospheres and climates, skills essential for long-term survival. Venus terraforming proposals. Sunshade. Large orbital mirrors reflecting sunlight away from Venus, cooling it over centuries. Atmospheric processing. Chemical or biological methods to convert CO2 to oxygen and sequester carbon bombardment. Redirecting comets to Venus, adding water and covering the surface, cooling through increased albedo and eventual oceans. Bioengineering, genetically engineered extremophile organisms consuming atmospheric CO2 and producing oxygen timeline for Venus terraforming, centuries to millennia, requiring sustained technological civilization and enormous resources. But if achievable, it would give humanity a second Earth-sized, Earth orbit proximity habitable planet, doubling our solar system's carrying capacity. Archaeological ethics. If Venusian ruins exist, how should we treat them? Preservation. Like Earth archaeological sites, Venusian sites would have immense scientific and historical value, deserving protection from vandalism or destructive resource extraction. Study. Careful archaeological methods, documentation, non-invasive investigation where possible. Respect. If any connection exists between Venusians and Earth life, panspermia, genetic engineering, migration, they might be our distant ancestors or cousins. We'd have ethical obligations to honor their legacy. Legal frameworks. Current outer space law, outer space treaty, moon agreement, addresses sovereignty and military use, but not. Archaeological heritage. International protocols for handling potential alien ruins would be necessary. SETI implications. The Venusian hypothesis has implications for the search for extraterrestrial intelligence. SETI. Look close to home. SETI traditionally focuses on distant stars, but intelligent civilizations might have existed in our own solar system. We should search planets, moons, asteroids, and interplanetary space for technosignatures. Temporal SETI. Intelligence might exist at different times rather than simultaneously. We might find evidence of past civilizations rather than current ones. Venus is a template, habitable world where intelligence arose and then conditions changed, leaving ruins. Message caches. Advanced civilizations facing extinction might leave message caches for future intelligence. These could be on their home world, if recoverable, on neighboring worlds, in stable orbits, or at obvious search locations, Lagrange points, poles, major impact craters. The Fermi Paradox. Revisited, the Fermi Paradox asks, where is everybody? Given the vast number of stars and planets, where are all the alien civilizations? Venusian answer, they existed but went extinct before achieving interstellar travel. Venus might be representative. Many civilizations arise on habitable planets, but planetary habitability is temporary due to stellar evolution, volcanic catastrophes, impacts, internal instability. Most civilizations face extinction before becoming spacefaring. This suggests intelligent life is relatively common. Long-lasting spacefaring civilizations are extremely rare. The Great Filter, the step preventing most life from reaching interstellar civilization, might be behind us. Going from non-life to intelligence is hard, or ahead of us. Surviving long-term is hard. The galaxy might be full of ruins on dead planets, but few active civilizations. The urgency. If Venus hosted civilization that failed to survive its planet's transformation, humanity faces similar urgency. We have limited time window, centuries, millennia, while Earth remains stably habitable to achieve sustainable civilization, become multi-planet species, develop technologies for long-term survival, mature ethically and socially to handle godlike technological power. Venusian history, hypothetical though it is, serves as motivation. We don't want to be the next archaeological mystery discovered by whatever intelligence evolves after us. The broader context. Life's timeline in the solar system. Let's zoom out and consider how the Venusian hypothesis fits into the broader timeline of our solar system's history, the deep history. 4.6 billion years ago. Solar system forms from collapsing molecular cloud. Sun ignites. Planets coalesce from protoplanetary disk. 4.5 billion years ago. Venus and Earth form, along with other terrestrial planets. Surfaces molten from impact. Heat and radiogenic decay. Both planets are hellish. 4.2 billion years ago. Surfaces cool and solidify. Late heavy bombardment delivers water and organics via asteroids and comets. Venus and Earth both potentially develop oceans, atmospheres, and become habitable. 4.2 to 4.0 billion years ago. Venus possibly habitable. If life arises, Venus biosphere begins. Earth also becomes habitable. Earth life possibly begins. Oldest isotopic evidence of life from 4.1 billion years ago, though disputed. 4.0, 2.5 billion years ago. Both Venus and Earth have life, if Venus developed it. Venus's rotation slows, possibly from tidal effects. Venus's magnetic field might weaken or disappear as rotation slows. Both planets have simple microbial life. 2.5, 0.7 billion years ago. Venus remains habitable, but is gradually warming as sun brightens. Water is slowly being lost. Earth develops more complex life. First multicellular organisms appear around 2 billion years ago. Oxygen levels rise on Earth due to cyanobacteria. Great oxygenation event 2.4 billion years ago. 700 million years ago. Venusian catastrophe. Runaway greenhouse begins. Massive volcanic resurfacing. Venus transitions to current hellscape over 10 to 100 million years. If Venusian civilization existed, this is when they face extinction or evacuation. 600, 500 million years ago. Earth's Cambrian explosion. Complex multicellular life diversifies rapidly. Possible coincidence with Venusian catastrophe or possible connection. Panspermia intervention. 500 million years to present. Earth develops complex ecosystems. Land life, vertebrates, mammals, primates, humans. Venus remains hellish, possibly with some life clinging to cloud layers, but no complex biosphere. The pattern. This timeline shows that Venus's habitable period preceded Earth's complex biosphere by billions of years. If intelligence takes a few billion years to evolve, as it did on Earth, Venus had sufficient time for intelligence to emerge while Earth was still dominated by microbes. We might be the second technological civilization in our solar system, not the first. And if so, we're inheriting a solar system shaped in part by the first. Modified orbits of mining operations, buried artifacts, possibly even genetic influences if panspermia occurred. The future. Looking forward, what happens to Earth? In 1 to 2 billion years, the sun will be 10 to 20% brighter than today. Earth's oceans will begin evaporating. If we don't actively manage climate or evacuate, Earth will experience runaway greenhouse warming, similar to Venus, becoming uninhabitable. Earth's habitability has an expiration date, so the pattern might be Venus, habitable 4.2 billion to 0.7 billion years ago, 3.5 billion year window. Earth, habitable 4.0 billion years ago to 1 billion years from now, 5.0 billion year window total, currently at 4.0 billion years in. Mars, habitable 4.03.5 billion years ago, 500 million year window, lost atmosphere early due to low gravity and no magnetic field. Each terrestrial planet had, or has, a finite habitability window. Venus's came first and ended. Earth's is current but will end. Mars's came early and ended quickly. This suggests planetary habitability is temporary. Every technological civilization on a planet has finite time. Achieving technological maturity before habitability ends is the only way to survive. Long-term spacefaring capability is essential for any species wanting to survive beyond its home planet's habitable period. The question, will humanity survive beyond Earth's habitability window? Will we become spacefaring and persist? Or will we go extinct, and in a few billion years, when the next civilization arises somewhere in the galaxy, will they wonder if anyone lived on the third planet from Sol before it became an inhospitable hothouse? Venus's example suggests our choices matter. Planets don't remain habitable forever. Technological civilizations must either expand beyond their homeworld or face extinction when conditions change. Could we prove it? The smoking gun scenario. What would constitute definitive proof of ancient Venusian civilization? Let's consider what discoveries would convince the scientific community. Level 1. Suggestive evidence raises questions. Multiple geometric features on Venus's surface at high resolution. Isotopic anomalies in Venus atmosphere consistent with industrial activity. Phosphine confirmed and correlated with biological markers. Surface features resembling ruins at multiple sites. Subsurface radar anomalies suggesting hollow spaces or structures. Scientific response. Interesting. Warrants further investigation. Alternative natural explanations still possible. Hypothesis remains speculative. Level 2. Compelling evidence. Shifts probability. Artificial materials detected in Venus atmosphere or surface samples. Alloys, plastics, ceramics with compositions not naturally occurring. Structures on Venus that require artificial origin after comprehensive analysis. Artifacts found on Moon datable to 700 million years ago, with materials sourced from Venus genetic evidence. In Earth life of non-terrestrial origin, compatible with ancient Venus. Multiple independent lines of evidence converging scientific response. Extraordinary claims, but extraordinary evidence presented. Hypothesis taken seriously. Major missions dedicated to investigation. Paradigm shift beginning. Level 3. Definitive proof, consensus acceptance. Recovered artifacts with clear technological function. Tools, devices, data storage. Deciphered information, mathematics, star charts, history, from Venusian sources. Imaging of structures undeniably artificial. Cities, monuments, infrastructure, on Venus or Moon. Direct evidence, intact technology, message caches, or extremely unlikely surviving. Venusians' scientific response. consensus acceptance, history rewritten, massive research programs, philosophical and cultural transformation. The most likely discovery scenario. If ancient Venusian civilization existed, the most probable path to discovery is 1. Orbital reconnaissance detects geometric anomaly or subsurface feature that seems unusual. 2. Targeted mission investigates, finds artificial materials or structures. 3. Confirmation mission verifies and expands findings. 4. Lunar discovery. Parallel investigation finds artifacts on Moon, confirming Venus origin through isotopic analysis. Sample return brings physical proof to Earth for comprehensive analysis. C. Consensus builds gradually as evidence accumulates. This process would take decades, perhaps 30 to 50 years from initial detection to consensus acceptance. Science moves cautiously, especially for extraordinary claims. Why haven't we found it already? If evidence exists, why haven't we found it? Several reasons. Limited exploration. We've barely explored Venus. A few low-res orbital maps, brief lander images, no systematic search for artifacts. It's like flying over Earth once at 100 kilometers altitude, taking some photos, and concluding there's no civilization below because we didn't see cities in our limited images. Wrong assumptions. We're not looking for it. Missions design their instruments and targets based on expected science, geology, atmosphere, potential current life. No mission has been designed to search for ancient civilization ruins. If you're not looking for something, you're unlikely to find it, even if it's there. Destruction of evidence, the resurfacing event. 700 million years ago, buried or destroyed most surface evidence. Remaining evidence might be subtle, degraded, or in inaccessible locations. Recognition problem. Even if we image ruins, would we recognize them? Highly degraded structures might look like natural geology without close inspection. AI trained on Earth, geological features might not recognize Venusian artificial patterns. Deliberate concealment. If Venusians survive somewhere, underground, atmospheric habitats, elsewhere in solar system, they might actively hide evidence of their past, not wanting to be discovered. The absence of evidence fallacy. We haven't found evidence, therefore it doesn't exist, is logically flawed. Absence of evidence is only evidence of absence when we've looked comprehensively and would expect to find evidence if it existed. For Venus, we haven't looked comprehensively. So the absence of evidence doesn't prove absence. It might just reflect insufficient investigation. That said, the burden of proof is on those claiming Venusian civilization existed. Speculation is valuable for directing investigation, but acceptance requires evidence. The appropriate stance is open-minded skepticism, unlikely but worth investigating. Living with uncertainty. The epistemology of deep time. One of the most profound aspects of the Venusian hypothesis is what it teaches us about knowledge and certainty regarding the distant past. The problem of deep time. Humans evolved to think on timescales of decades to perhaps centuries. Our civilizational memory, through writing, extends only a few thousand years. Our species, Homo sapiens, has existed only 300,000 years. Our ability to investigate ancient history through fossils and geology reaches back millions to billions of years. But with decreasing resolution and increasing uncertainty, the further back we look. Billions of years of history, most of Earth's past, virtually all of Venus's transformation, lie beyond direct human memory or cultural memory. We reconstruct these vast timescales through indirect evidence, radiometric dating, crater counting, isotope ratios, sedimentation rates, making inferences from present observations about ancient conditions. This reconstruction is surprisingly good for geological processes. We can determine when rock layers formed, when impacts occurred, when continents collided, with precision of millions of years for ancient events. But for biological and especially civilizational events, our reconstruction is much less certain. Biological events. Fossil record is sparse. Only a tiny fraction of organisms fossilize. Soft-bodied organisms rarely preserve. Behaviors don't fossilize. We can miss entire ecosystems, organisms, or biological processes if they left no fossil evidence. Civilizational events. Civilizations leave artifacts, but artifacts degrade. On Earth, we have good archaeological records going back 10,000 years, start of civilization. Harder evidence 100,000 years ago, Paleolithic tools. Essentially, nothing recognizable beyond 1 million years ago. If human civilization suddenly ended today and another species evolved intelligence 100 million years from now, would they find evidence of us? They'd find geological signatures, Anthropocene stratigraphic layer with plastics, concrete, altered isotopic ratios from nuclear testing, mass extinction of species, climate anomaly, rapid CO2 increase in ice cores and ocean sediments, possibly some artifacts in protected locations, underground, dry caves, Arctic ice, but most cities, buildings, infrastructure would be eroded or subducted. They'd know something unusual happened, but might not recognize us as technological civilization unless they found well-preserved artifacts or fossils clearly associated with technology. Implications for Venus. If human civilization would be barely detectable after 100 million years, how detectable is Venusian civilization 700 million years later after catastrophic resurfacing? The answer, possibly not at all, unless we search very carefully in protected locations or find evidence on bodies without geological recycling. Moon, asteroids. The limits of knowledge. This forces humility about what we can know about the deep past. There might be entire chapters of solar system history, civilizations, migrations, catastrophes, that are completely unknown to us because evidence didn't preserve or we haven't found it yet. This doesn't mean we should believe unfounded claims about ancient aliens or lost civilizations without evidence. It means we should acknowledge uncertainty about the deep past. Remain open to discoveries that would revise our understanding. Investigate systematically rather than dismissing possibilities a priori. Distinguish between no evidence found and evidence proves it didn't happen. The Venusian hypothesis is speculative, but it's not absurd. It's based on Venus's geological history showing it was habitable. Sufficient time for life and intelligence to evolve. Known mechanisms for planetary habitability, loss. Physical possibility of evidence, preservation in certain locations. What's missing is actual evidence, and that's the key distinction. Plausible speculation, worthy of investigation, but not established fact. Bayesian thinking. How should we assign probability to ancient Venusian civilization given current evidence? Prior probability. Before considering Venus specifically, what's the probability that any given habitable planet develops intelligence? Unknown, but non-zero. Let's estimate 0.1% to 10%, very uncertain. Venus-specific factors. Venus was habitable for billions of years, increases probability. We have no evidence despite limited search, slightly decreases probability, but not much given limited search. Runaway greenhouse would destroy surface evidence, doesn't decrease probability of past existence, just of finding evidence. Posterior probability. Somewhere between 0.1% and 10%, most likely in the 1 to 5% range. Unlikely, but not absurdly so. Worth investigating, but not assuming. As we gather more data, we'd update this probability. Finding structures on Venus would increase it to 90%. Comprehensive search, finding nothing, would decrease it to 0.1%. This Bayesian framework lets us hold uncertainty rationally, assigning rough probabilities rather than binary believe, John disbelieve, updating as evidence accumulates. The meaning question. Does it matter? Finally, let's confront the existential and philosophical question. What would it mean, psychologically and philosophically, if Venus once hosted the solar system's first civilization? We are not special. Human exceptionalism, the idea that humanity is unique, unprecedented, the pinnacle of creation, would be shattered. We'd be the second act, not the premiere. Our achievements would seem less impressive in context of predecessors who existed for millions of years before us. But this might be liberating rather than diminishing. We'd be part of a larger story, one civilization among potentially many in cosmic history. Our struggles, achievements, and questions would connect to those of beings who faced similar challenges millions of years before us on another world. The tragedy of impermanence. If Venusian civilization existed and is now gone, extinct, or scattered, it would underscore the tragedy of impermanence. Civilizations, like organisms, are mortal. Nothing lasts forever. Even millions of years of civilization eventually end. This could inspire two responses. Nihilism. If even million-year civilizations end, what's the point? Everything is ultimately futile. Urgency. Impermanence makes the present precious. Our choices matter because we have limited time. We should make the most of our civilization's window, striving for knowledge, beauty, justice, and survival. The connectedness. If Venusians came to Earth through panspermia, migration, or influence, we might literally be connected to them. Venus and Earth's life could share common origin. We might be distant cousins or even descendants of Venusian survivors. This would change our relationship with Venus. It wouldn't be just another planet, but our ancestral home, at least partially. The hellscape we see would be tragedy, the destroyed homeworld of our predecessors. The warning. Venus's cautionary tale becomes more visceral if it actually hosted civilization that failed to save itself. Climate change wouldn't be abstract planetary science, but demonstrated existential risk. It killed an entire civilization. This could motivate action on Earth's climate crisis. If we're heading toward Venus-like runaway warming, we're not currently, but positive feedbacks could potentially push us that direction over centuries or millennia. The Venusian precedent would be terrifying motivation to change course. The hope. Conversely, if Venusians survived through evacuation, adaptation, or transcendence, they demonstrate that planetary catastrophe isn't necessarily the end. Intelligence can find ways to survive, to adapt, to persist even when the homeworld becomes uninhabitable. This could inspire hope about humanity's long-term prospects. We might survive beyond Earth's habitability, beyond the sun's eventual expansion into a red giant, beyond the solar system itself. Intelligence, once emerged, might be essentially immortal if sufficiently capable and adaptable. The contact fantasy. Many people fantasize about first contact with extraterrestrial intelligence, the moment when humanity meets alien minds and everything changes. The Venusian hypothesis offers a twist on this fantasy. First contact might not be with distant aliens from another star, but with neighbors from the next planet over, or their descendants, or their ruins. The first aliens we meet might be much closer than we imagined, in our own solar system, waiting in atmospheric habitats or underground cities, or preserved in ruins from 700 million years ago. This creates unique excitement. We could potentially discover Venusian civilization within our lifetimes. We don't need to wait centuries for interstellar travel. We just need to send better missions to Venus and look more carefully at the moon. The Fermi Resolution. Where is everybody? Might be answered. They were on Venus. They're gone now. We're the next iteration, intelligence arising again in the solar system, looking out at the cosmos and wondering if we're alone, not realizing we're standing on the graves, metaphorically, of those who came before. This would resolve the Fermi paradox in melancholy way. Intelligence is common enough that it arose in our own solar system, but survival is rare enough that even the first civilization couldn't persist. We're not observing alien civilizations because most civilizations don't last long enough or expand far enough to be detectable. The galaxy might be full of ruins on dead planets with only rare instances of currently active civilizations. The mirror. Venus would become a mirror for humanity, showing us what could happen if we fail to manage our planet carefully, if we don't achieve spacefaring capability before conditions change, if we don't mature sufficiently as a species. Looking at Venus wouldn't just be planetary science, but confronting our potential future. Every image of Venus's hellish surface would carry emotional weight. This could be Earth in a few million years if we're not careful. this beautiful blue world could become orange, lifeless inferno. Venus would haunt us. The inheritance. If we find Venusian artifacts, technology, or especially information caches, we'd inherit knowledge from a civilization that existed far longer than ours. What wisdom would they share? Scientific knowledge about physics, chemistry, biology, potentially far beyond our current understanding. Engineering principles for managing planetary climate, achieving space travel, building sustainable civilization. Philosophical insights from millions of years of contemplating existence. Warnings about mistakes they made, advice for avoiding their fate. Art, culture, history, expanding our sense of what civilization can be. This inheritance could accelerate human development, helping us avoid pitfalls and advance more rapidly. Or it could be dangerous, technologies we're not ready for, knowledge we'd misuse, or simply being overwhelmed by confronting intelligence so far beyond ours. The responsibility. If we're the second civilization in this solar system and the first is gone, we bear responsibility for carrying forward the torch of intelligence and consciousness in our part of the galaxy. We become not just humanity surviving, but the continuation of a lineage of solar system intelligence. This would make our choices more weighty. We're not just deciding humanity's fate, but potentially the fate of intelligence. In this region of space, if we fail, the sun's third and fourth planets will both be dead, and it might be billions of years before intelligence arises again here, if ever. The story. Ultimately, the Venusian hypothesis is a story, one of the grandest stories we could tell. It's the story of a planet that was beautiful, that birthed life, that developed intelligence. A civilization that thrived for millions of years, achieving wonders we can only imagine. A catastrophe that destroyed their world, forcing impossible choices. Survival attempts, migrations, adaptations, or eventual extinction. Legacy left behind in ruins, in artifacts, in genetic seeds on a neighboring world. A new civilization arising on that neighboring world, eventually wondering about their predecessors. Discovery, understanding, connection across vast time. This story matters, even if we never prove it true, because it expands our imagination about what's possible, about deep time, about the rise and fall of civilizations, about our place in cosmic history. And if the story is true, if Venus actually hosted civilization, then discovering it and proving it would be the most profound moment in human history. The day we learned we're not alone in intelligence, not first in achievement, not the primary story, but a continuation of a story that began before us and might continue after us, written across planets and eons. Closing. The evening star beckons. As you settle into sleep tonight, perhaps you'll dream of Venus, not as we see it today, that blazing inferno shrouded in acid clouds, but as it might have been billions of years ago. A blue marble, much like Earth, with oceans lapping on shores, continents greening with life, clouds drifting across skies, and somewhere, perhaps, beings looking up at the night sky and wondering about that pale blue dot orbiting farther from their sun, wondering if life might exist there someday. Perhaps you'll dream of that ancient civilization in its glory, cities whose architecture we can't imagine, technologies we haven't conceived, art and music and literature from millions of years of cultural development, scientists mapping their planet and their solar system, knowing their world is changing, knowing the bright sun that gives them life is also their doom, trying desperately to understand how to save their world or how to escape it. Perhaps you'll dream of the catastrophe, the slow horror as oceans evaporated, as temperature rose past tolerance, as the last refugees became uninhabitable, as survivors made impossible choices. Retreat underground into sealed bunkers, hoping to outlast the catastrophe. Build floating cities in the clouds. Point their telescopes at the next planet outward, where oceans might be forming, or accept extinction with dignity, leaving messages for whoever might come after. Perhaps you'll dream of the migration, the desperate journey across space in ships or on rocks blasted from Venus by impacts, carrying with them whatever they could save of their civilization, their biology, their knowledge, landing on a harsh snowball world that was nevertheless paradise compared to dying Venus, seeding Earth with their life or their genetic material, becoming the ancestors of everything that would follow, including eventually you. Or perhaps you'll dream of discovery. Future humans exploring Venus with advanced robots and protected habitats, drilling into the resurfaced rock, finding a chamber preserved beneath the lava, inside it a crystalline storage device waiting 700 million years to be found, activated by human technology, projecting holographic images of beings who look at us across the vast abyss of time and say, in mathematics and symbols we eventually decode, we were here, we lived, we loved, we wondered, we are gone, but we left this for you. Learn from us, do better, survive, remember us. And perhaps as you dream, you'll float above Venus in your mind's eye, seeing not the hellish world we know, but both worlds simultaneously. The ancient paradise and the modern inferno, superimposed, reminding you that worlds change, that habitability is temporary, that civilizations rise and fall like waves, that we are not permanent fixtures of the cosmos, but brief flowerings of consciousness in the vast garden of space and time. The evening star, Venus, shining so brightly in twilight, might not just be a planet, but a monument, a grave, a warning, a promise, a mystery waiting to be solved by the civilization that arose after them on a more fortunate world that got just a bit more time in the habitable zone. Whether Venusians existed or not, whether we ever find proof or it remains eternal speculation, the possibility changes how we see that brilliant point of light in the evening sky. We see not just a planet, but a world with history, a place where life might have looked up at us before we existed, a cosmic neighbor that might have stories to tell if we learn to listen, ruins to explore, if we develop courage to venture into the heat and pressure, knowledge to inherit if we prove worthy. Sleep well, humans of Earth, third planet from the sun, current holders of the torch of intelligence in this solar system, standing on a world that was lifeless when Venus might have been alive, thriving on a planet that will someday be hellish when we're long gone, unless we're wiser than those who came before, unless we learn from their example, if they existed, and do better. Tomorrow when you wake and look at the dawn or evening sky and see Venus shining there, perhaps you'll wonder, what stories does that light carry? What history has that world witnessed? What civilizations rose and fell while Earth was still silent? What knowledge waits in the darkness beneath those clouds? What would the Venusians think of us if they could see what their neighboring world became? If they could see that life did eventually flourish here, that intelligence did arise, that consciousness once again looks outward from an inner planet and asks the eternal questions they once asked? And perhaps you'll resolve to help ensure that billions of years from now, when the sun grows brighter and Earth begins following Venus's trajectory toward greenhouse hell, humanity will not repeat the Venusian tragedy. We'll have already become spacefaring, multiplanetary, perhaps even interstellar, ensuring that consciousness, which arose in this solar system, whether once on Venus or once on Earth or twice across both worlds, will not be extinguished, but will continue, spreading through the galaxy, making sure that the story has no final chapter, that intelligence once sparked will not be snuffed out, but will burn eternal. Good night, descendants of Earth, possible relatives of Venus, children of the Sun, heirs to the solar system's long history of life and perhaps of civilizations. Dream of worlds that were and worlds that might be. Dream of connections across time and space. Dream of the first civilization, whether it existed on Venus or exists only in our speculation, and let that dream motivate you to ensure that we are not the last. The evening star watches. Venus remembers, perhaps, and we inherit the future, with all its challenges and possibilities, standing on a world that was once like Venus in the distant past, and might become like Venus in the distant future, unless we prove worthy of survival, worthy of the gift of consciousness, worthy of the responsibility to carry forward the light of intelligence that might have first kindled on our neighboring world before Earth was ready to receive it. Sweet dreams of ancient seas on Venus, of civilizations lost to time, of knowledge waiting to be discovered, of connections across the abyss, of humanity's future among the stars. May you wake tomorrow with wonder at the cosmos, appreciation for our blue world's fragile habitability, determination to protect it and to expand beyond it, and curiosity about what secrets Venus still holds in its depths, waiting for us to develop the technology and the wisdom to uncover them. The first civilization, if it existed on Venus, is gone, but their story, whether history or speculation, remains to inspire us, to warn us, to remind us that we are part of something larger than ourselves, larger than our species, larger than our planet, a cosmic story of matter becoming life, becoming consciousness, becoming civilization, becoming something more, written across worlds and eons, with chapters yet unwritten that depend on choices we make today. Sleep well, dream deep. The planets turn in their ancient courses, and tomorrow continues the story, with you as part of it, wondering about those who came before, and those who might come after, living in the brief moment between cosmic past and cosmic future that we call now, the eternal present where all choices are made and all stories unfold. Good night, Earth. Good night, Venus. Good night, solar system, with your secrets and mysteries. Good night, consciousness, wherever it arises and however long it persists. May we all endure long enough to understand, to connect, to remember, and to transcend the limitations that would confine us to single worlds with finite habitability. The evening star sets. Venus disappears below the horizon. But the questions remain, hanging in the darkness, waiting for dawn when we rise and continue seeking, continue wondering, continue dreaming of what was, what is, and what might yet be. Rest well, dreamers. Tomorrow, we explore further.